So welcome. So tonight I want to talk about the Django ORM. Django is undoubtedly, it's one of the most powerful web frameworks in existence today. And one of those sources of power is its ORM. But despite its great documentation, it can be extremely confusing. And I've come into numerous projects which were plagued by poor usages of the ORM, causing headaches, heartaches for the developers, and often greatly degraded performance. So here today, I want to pass on some of what I've learned, some of the problems I've seen in all these years of using Django and its ORM. And in order to do that, I'm using beer, at least building an application around beer because I like beer. And don't really need much more reason than that. So the first obvious question for anybody new to Django is, what the hell is an ORM? That's a really good question. The answer is, it's an object relational network, which is totally self-explanatory. Anybody understands that. But not really. The ORM is actually the way that Django communicates with the database. And really it can communicate with any database through this ORM. Using this, it can talk to a SQLite database, MySQL, PostgreSQL, Oracle, even Microsoft SQL Server. And you don't have to know anything about how to connect to it, the intricacies of the libraries, or differences in the SQL language between the different database engines. You don't have to know how to deal with any of that, because Django's ORM knows all of that and deals with all of it for you. The other thing that it affords is you don't have to learn another language, because SQL really is. And talking to database usually requires learning this arcane SQL language. Now, you can just let Django do it for you. So now let's start with some models. Wrong type of models. You don't get to work with Cindy Crawford and random guys here. Actually, we're working with Django models. In a database, every type of data is stored in a table. In Django, those are represented in what we call models. One model equates to one table in the database, and it all starts with just this import. Now, the exact details of how you draw those lines, split up the types of data, is a topic for a whole different discussion. But hopefully you'll get the general idea as we continue if you're not already familiar. So let's start out building the first model here. As I mentioned before, you have to import the models from Django. Then start with, since we're working with beer here, we're going to create a model to store breweries. With those breweries, just store name, description, location, pretty basic stuff. But the astute people here might notice a couple of strange things. The first thing I want to cover is the name of the model, breweries. Now, it's a perfectly legitimate name for a model and for the corresponding database table, but it kind of flies in the face of convention, and it makes for some slightly awkward code. Specifically, the plurality. The more common convention is to use a singular form. It's not a hard and fast rule, just more of a common convention, both in Django development and in database design in general. It's really just a de facto pattern followed by the community at large and considered a best practice. Now, the other thing here, which is far less obvious, because it's actually something which is not here, is a primary key for the model. In database design, you use a primary key to identify each record individually, and it's typically an auto-incrementing number. Of course, we could just make the name field unique and identify breweries by that field. But what if two breweries come along with the same name? It has been known to happen. So why didn't I include a primary key field in this model? Well, mostly because I don't have to, and because I'm lazy. It's one of the magical pieces of Django. If you don't specifically add a field with an attribute of primary key equals true, It adds a field for you behind the scenes named ID. You don't even have to think about it. All you have to do is think about the fields which actually matter to you, the ones describing your data. So just be lazy and don't bother adding primary keys when you really don't have to. So as we continue, we need to add some more models. We want to track a list of styles for these beers because there are a crazy number of them. And of course, we want to store a list of the beers themselves. Cool. So moving right along, that's simple. Except it's not that easy.
So in this case, what's the table name inside the data?
So the table is the same as the model name.
Oh, okay.
This beer model actually has a couple of problems, though, and specifically in those foreign keys. So let's start with that weird on-delete part. This is something that is relatively new to Django, so you may not be familiar with it. I believe they were originally introduced in Django 1.9 or 1.10, but coming with Django 2.0, which is the next release, they're going to be a required argument. So it's good to know about now. So what's the deal? First, to understand on-delete, you need to know a little bit about foreign keys. So what the foreign key does is it points to a single instance of another model. What this means is, let's say we have a single beer, let's call it Kill Lifter. It can be associated with one single style. So let's say it's associated with the style of Scottish ale. And then that beer is produced by one particular brewery. So let's call that brewery Four Peaks. Now, where the on-delete comes into play is if you try to delete one of those associated records. Let's say for whatever reason, somebody tries to delete the Four Peaks brewery from the database. This beer happens to be linked to that brewery, and deleting that would cause havoc in our system. So we need to tell the beer what to do when that happens. In this case, do nothing sounds like a somewhat logical thing to do, except that it's really not. Do nothing actually means that Django will not try to interfere in the deletion, which causes problems when it talks to the database to do that deletion. Because the database wants to maintain what's known as referential integrity. This means that a beer record cannot point to a brewery record, which has already been deleted. So when you have this do nothing and you try to delete one of those associated records, boom, big error, bad things happen. Moral of the story is just don't use do nothing unless you are an extremely advanced user and have a contingency plan set up in place for that. So what should you do instead? So there are a number of options available to you, and this link here is to Django's documentation, and I will be providing this presentation afterwards so you can get all the links, all the content. In this case, I want to show two different options. So for the style, we use protect. And what that means is if we have this Kilt Lifter beer in the database and it's linked to a style of Scottish ale, if somebody goes to delete that style, Django will actually stop it in its tracks and say, no, you can't do that because there's a reference to it. Okay, so what about this cascade on the brewery? It's probably not the best option for this project and for this use, but I wanted to show it here. What it does is, if somebody were to go in and delete the brewery associated with this beer, it would also delete every beer that's associated with that brewery. So it's a cascading delete. It deletes all referring records. So now those are fixed, so let's move on. Actually, foreign keys still have an issue. Looks mostly good, except a little bit more Django magic here. These field names are a little off. So in the database, these contain the primary key of another record. Its ID, as we talked about before. And these are in fact the field names that we want in the database. But thing is, thanks to Django's ORM, you don't deal directly with those foreign keys. Instead, you deal with instances of models. So remember when I said you don't have to deal with a model's primary key? I really meant that. And this is another example. So instead, the model should look like this. So remove the underscore ID, and it's good to go. In fact, there's even more magic going on behind the scenes. So in the database, the style and brewery field will be stored in fields named, respectively, style underscore ID and brewery underscore ID. And an instance of the model, of this beer model, will still have attributes named style underscore ID and brewery underscore ID with those IDs. But you don't ever have to or really want to deal with those because these style and brewery attributes will give you direct access to other models with no extra effort. So what I mean by that is, given an instance of a single beer, you can reference beer.style.name or beer.brewery.name. And it gives me that value instead of having to look up the other models with the foreign key IDs. And as an additional bonus, it makes creating new instances of objects ever so slightly easier. So this is an example of how you would create a new brewery, style, and beer. All looks great, especially if you have a background in databases. It makes absolute sense. You can see here you're assigning to the brewery ID and the style ID. That's exactly what you would want. But as I mentioned, you never have to actually deal with those ID fields or the .id of an instance. Django does that for you. So you can just get rid of the ID altogether and just work directly with the instances. And Django handles everything in the back end. So it's slightly less code, less to worry about, and again, Django handles the relationships for you. So now, for the last of the models, we need a list of venues. You have to know where to get the beer. So, simple enough model, but with two different things. You may notice a slight difference with how it's built with all these type things up top. And what this is doing is building a list of selections for the venue type field. The first three values, the type bar, type brewery, type food truck, those are what's actually stored in the database. And then these other three are what would be presented to a user. They're the friendly values. So why did I build it like this instead of a separate table like with the styles? There's a couple of reasons. The main one is I only want to support a small list of types. And they're unlikely to change frequently. In fact, they may never change. So it doesn't make sense to incur more database overhead for them. I would have to have another database lookup, and I just don't want that. And the second reason is that I might need the application to behave differently for a different venue type. So if the code is depending on these values that are stored in the database, you always want to have a strict, well-defined list of choices. And then on the flip side, with the beer styles, there's something which are constantly changing and constantly being added to, and one style is unlikely to need different application behavior than another. So that makes the styles a great candidate for a lookup table. So another thing I did a little differently here is this many-to-many field. It allows for a different kind of a relationship from the regular old foreign key. This means that one venue can have many beers, and one beer can be at many venues. And to manage this, Django actually creates a new database table in the background to manage the relationship. But it's another thing that you don't have to worry about because Django does that magically. And you only have to deal with these attributes. And finally, you may notice I added a related name attribute to this many-to-many field. And it's something you should really get in the habit of using on all relationship fields, whether they're foreign keys, many-to-many fields, or the untouched on one-to-one field.
Quick question, yeah. Where you have the many-to-many to a beer table, can another model also have a many-to-many to the beer table?
Absolutely. You can have as many relationships as you want between the tables.
No, I'm saying like if you have venue 2, as an example, right? And then that model would have a many-many to beer.
Yes.
So would that create another table then, a second background table?
Yes, it would.
Oh, it will.
Yes. So they would be separately managed relationships.
Okay.
So this related name, what this is doing is this is setting up what's called in Django a reverse relation. So that means that with this single field on this model, I can refer to, given a single venue, I can refer to venue.beers.all to get all the beers available there. Or on the flip side, given a single beer instance, I can say beer.venues.all using that related name. So it actually creates a virtual field on the other model so that you can refer back to these. So, got the models built, little time passed, worked on building up the application, added some data, some views going, and then it starts to slow down. See that you're getting tons of queries, just hitting the database constantly. So if you look here, this is a relatively small amount of data. 4 venues, a total of 16 beers available between them. And this page, if you look right here, is calling out to the database 43 separate times. Doesn't seem very optimal. Now, imagine if you had the same page with 100 venues with 20 beers each. How many times would that be calling out then? So something tells me that's just not sustainable. And for anyone who's wondering, this sidebar I have here is Django Debug Toolbar. I've provided a link to that. It's one of the best tools you can use when you're building a Django application. It's incredibly helpful, even if only for discovering issues like this one. So now we've identified an issue, need to figure out why is it happening and how do we fix it. I'm getting it. And yes, make sure to disable the debug toolbar in production. You don't want that showing to your users. So the first place we want to look is the template. This is what's generating the HTML for the page we're looking at. And at first glance, there is nothing wrong with it. It seems pretty innocuous. We're just displaying names, links, and account. So what could be wrong? Well, the problem is actually with how Django handles query sets and when it pulls data out of the database. And to be clear, it isn't actually a problem with Django. Django handles all of that very elegantly, very efficiently. The problem is with this code just hoping that Django will be a little more magical than it really is. So, now what are the problems here and how do we solve them? So let's start at the top. This totally harmless statement right here is actually generating a separate SQL query for every venue in the listing. So on the current page, that is generating 4 more queries. But this is just using the .count method, which is recommended in the Django docs, saying this is the most efficient way to count the objects in a query set. And that's true. You should definitely prefer using .count over, for instance, using the Python method of len to get the length of a query set. This count will be far more efficient in 99% of cases. The problem here is that we're doing it inside of a loop. And every time the method's called, it's executing another SQL query to count the number of results that would be returned. So that brings us to the first optimization and the first slightly more advanced usage of the ORM. So now we need to look at the view. This view is what's used to generate the page. Very simple. Django has its built-in class-based views, so you don't have to do much. We've just got the 2 lines here telling us that we want a list of venue instances. But it isn't quite enough for the amount of data we're trying to load. So we need to tell Django to be a little smarter about how it retrieves the data. And since we're starting with the count, we're going to look at annotations. So instead of that simple 2-liner and just telling it what model to use, we have to use an explicit query set. One of these class-based views requires either a model or a query set. So if you're unfamiliar, this syntax might seem a little weird, a little arcane, and it can be. But what it boils down to is this. The .annotate method on a query set is used for adding fields to every record in the query set. So in most cases, you're trying to add calculations of some sort to every field. And that's exactly what this is doing. This code is saying, for every venue in the database, add a field named beer_count, which is a count of the beers available at that venue. And again, I provided a link to the documentation because it is wonderful and it will tell you a lot more than I can tell you here. So now that the view is updated, we just need to update the template to use the new field. And then we're down from 43 to 39 queries. Not a huge change, but it's a start. And we can do better. So the next thing to look at is the beers themselves. So if you remember from the models, the beers are a many-to-many field, meaning it's just a relation to another model. So what this means in this sense is that every time we try to get the beers associated with the venue, we're executing another SQL query to traverse that relationship. And since this is also happening inside of a loop, this is another query for each venue on the page. So to prevent this, we need to look into something known as prefetching. So what is prefetching? How does it work? Well, the docs, again, are going to be your best friend here. But to sum it up, prefetching is a way to preload and cache those related objects. So keep in mind, this is only useful and usable for many-to-many fields or the reverse relation of a foreign key. So that makes these beers a perfect use case for it. But for instance, a beer's style would not be applicable here because that is a relation to only a single instance. But we'll get to that one later. For now, you just need to know that we're caching all of the beers related to all of the venues on the page. So what's that extra bit gain us? Another 3 queries knocked off. But the last one took off 4, so why is this only 3? Well, that's because with the annotate, it actually appends to the existing query. With a prefetch related, it instructs Django to execute a second SQL query for that caching operation. So the first will be to retrieve all of the venues, and then the second query is to retrieve all of the beers associated with that. And that's where the caching comes into play. So it's good progress, got rid of 7 queries, but can still do better. Before we do though, got a little bit of sidetrack to a different view, just to explain a little more. So this is the beer list. These are all the beers in the system. As you can see, it's much simpler, but it's got a similar issue. 7 beers and 17 queries. And that's just kind of ridiculous. So let's tweak this one really quick. So this is the template. I copied this out of the previous, so it's nothing we haven't seen before. So what's the problem here? What are we looking at? What we're looking at are these related objects. So if you remember, when you look at related objects inside of a loop, it's executing another SQL query to retrieve that related object. So we need to do something about that because we don't want all of those queries. Now, these two happen to be foreign keys as opposed to the many-to-many field before. So that means there's only one brewery per beer, only one style per beer. And that's an important fact in constructing the optimization. So again, we have a very simple view, just like the venue list looked when we started, except it's 4 beers. And again, we need to change it from a simple model to an explicit query set. The difference this time is that we're using select related. And this is because, again, those are foreign keys pointing to a single related object. And what this does is it consolidates it into a single query so that every record that comes back already has those related objects in its data set. So now when we go through the loop, it doesn't have to call back to the database to get those relations. So what's the result? 3 queries, just from a small change. It's perfect. So select related clearly is pretty powerful, can do some huge optimizations very quickly. So we want to take this and apply it to the venue list. Try to cut those queries down a little more. So what we're trying to accomplish here is the same thing, really. We want to issue a select related for these beers. But the problem is we did a prefetch related to get them. So how do you do a select related on a prefetch related? It's just getting confusing. And I will admit the next part can be a little tough to digest. It's actually a new part of Django, which I recently learned myself. And I've got a link to the documentation again. This is a prefetch object. So this allows you, instead of having just that simple name for telling it what to prefetch, it allows you to actually control the query set that's used when it's pulling back those related objects. And if this query set looks familiar, it should, because that is pulled directly from the beer list. It's the exact same one that I just used. So that will pull back, again, all of the related objects in a single query. And I know I'm glazing over this a little bit fast, but again, I will say the documentation is really going to be able to help you out a lot more here. And I'm trying to give an overview and show some of the things that can be done. And show some of the tools. And here's another example. So it's 4 queries down from 43, just from prefetching a few lines of code. The nicer thing about this query count is that compared to the other one, this one will not ever increase. Can add as many venues, as many beers, as many styles as you want, and that will stay at 4 queries. The other one was constantly growing the more records got added to the database. So now with those tools, site is great, functional, efficient. And then since it's a beer website, hipsters and beer snobs come in droves, and they turn their noses up at that simple list of beer styles. They don't want just an IPA. They want English IPAs, West Coast, East Coast, dry hop, wet hop, whatever. And so you realize you need a way to categorize sub-styles. So create a sub-style model, because that's clearly the right thing to do, right? I mean, there's styles and there's sub-styles. Actually, no. This way would lead to a big mess. Not only is it another unnecessary table, but if you do this, you then have some data linking problems, because then you have to figure out, does a beer get linked to a style? Does it get linked to a sub-style? Does it have to be linked to both? That's just unnecessary worry. You don't want to worry about that. But there is a better way. This parent attribute is a self-referential or a recursive foreign key. You can see I just used the string self here, and that tells it that it's creating a relationship with itself. So this way you can create an entire tree of styles with infinite depth and breadth. And now the hipsters and beer snobs of the world will rejoice. But now that you got this, there's another problem. Now that they're all happy, they're using Cite more, starting to complain again. They want to find the perfect beer. And the criteria for the perfect beer are not simple. They can be pretty specific, pretty crazy, but you have to cater to your crowd. So you want to build a page to display some of the most optimal beers they can find. How the hell do you do all of this in an efficient way without issuing all kinds of database queries and a bunch of server-side processing? I wouldn't personally want to deal with that, but this is where we introduce the power of Q. Wrong Q, but similarly powerful. This wall of text here, I'm not expecting you to digest all of this, but again, this will be available. And this link to the documentation does a great job of describing it. But this actually takes that entire previous slide and creates a query out of it, a single query. And I'll admit, this even confused me a little bit when I was writing it. It's not a simple one. Damn hipsters. But I want to point out a few things here. So the first thing is all these joining operators. If you've done any work with bitmath, they might seem familiar. And what these do is they let you join these different query statements in different ways. You can use the pipe for an or you can use the ampersand for an and. And this is actually, using QObjects is the only way that you can execute an OR query using the Django ORM. Another important thing is the way that we're constructing all of this. So we don't have to build just a single giant query set filter statement. We can actually split it out into many statements, into many variables, to help keep the code more readable and understandable. And that's actually really important. Code is only written once, but read many times. And Django itself actually goes out of its way to be readable and friendly to developers. So this makes the individual pieces of the query reusable if you want to build multiple queries out of the same building blocks. Rakesh?
Do you need a query set for the server viewer? Or yeah,
That
do
is
you need that one?
not necessarily, but just trying to show the way you can combine them in here.
Okay.
And again, those same things could be reused to execute different queries in different ways. And of course, no self-respecting beer snob is going to want to drink something from a particular big name brewery buying up all the little ones. So we need the negation operator for a not query. And that allows us to exclude a set of records from our results. And that would be this tilde right here. That's how you do a not. And finally, one thing you might have noticed in all of this is that I'm not actually doing a filter anymore. I'm not operating on a query set. All I'm doing is building a query from the building blocks. And I'm able to do this because of the way Django evaluates queries. It does lazy evaluation, meaning it never actually generates any SQL. It never talks to the database until it really, really has to at the very last moment. And in fact, even when I do a filter on the model, it still isn't executing a query yet. Django really will be as lazy as it can, and that's a very good thing. This can drastically cut down the number of database queries that you're executing, as long as you're careful about it. The only time it actually goes and talks to the database is when you try to use the results. So if you do something like printing them or turning them into a list, there are a few more ways that can happen. And again, documentation has a list of all of those. And I feel like I've taken up enough of your time. So anybody have questions? Yeah.
So is this like tightly coupled to Django, or can you rip out the ORM and use something else?
Like using the rest of the Django framework with a different.
Yeah, the different database.
Yeah, you can
later.
You can absolutely use a different database layer if you want to.
Like Olympic or something like that.
Yeah, definitely could. Django it's built in a way that you don't have to use everything together. It just works very well together. So you could use Django with a different ORM or the Django ORM with a totally different framework. Any other questions?
Can I order a server viewer?
Yeah, bar down the street.
Yeah. So for the Django 2.0, what are the new or different things, or why is it 2.0 and not 1.15, 16?
It would be 1.12, but
Yeah.
one of the reasons is in Django 2.0, they are dropping support for Python 2. And in fact, I believe they're only doing 3.5 and 3.6. There was a lot of debate on whether to support Python 3.4 because it's got end of life pretty soon. And I believe it's getting dropped, but I'm not absolutely certain on that. The on-delete statement that I brought up, or on-delete argument for relationships will become a required argument. Yeah, there was actually a good bit of debate on whether to just continue with the 1. Series, but they wanted to introduce some breaking changes, so
Yeah, might as well.
2.0 it is.
All right. Is there any new features for templates similar to the crispy forms, where it's a little bit more I guess, built in or generic?
So in Django 1.11, they introduced form widgets are rendered from templates now. There isn't the all-encompassing form template. It's just for the individual widgets, so it's not quite as robust as, say, crispy forms or something like that. Another thing that's getting introduced in 2.0 is actually a simplified URL syntax, so you don't have to learn regular expressions anymore. Because that's one of the banes of learning Django, is having to learn that cryptic language that I still hate to this day.
Cool.
Well, thank you everyone for coming. Keep in touch. Everything will be on the Django Phoenix GitHub account. The code that I wrote for this is already up there. There's a beer tracker application. I would not say that it is entirely best practices for everything. That wasn't my goal. But for the ORM usage itself, I would say it is. Thank you.